Good morning to one and all. In this video lecture, we would like to discuss about the concept registers. So we entered into the fifth unit register concept here. Introduction to registers. So flip-flop, basically, in order to define what is a register, first we would like to know how to store n bit of information. Let us have, if we consider my 4 bits of information, 1101. If I would like to store this bit of information, simply I would like to consider 4 flip-flops. So in order to store the data. So in the first flip-flop, I will have 1 bit of information, and in the second flip-flop, and in the third flip-flop, and as well as in the fourth flip-flop. So in this particular condition, each flip-flop we can understand that will store the information of 1 bit. Like therefore, we can store the information 1 in the flip-flop 1 and 1 in the flip-flop 2 and 0 in the flip-flop 3 and 1 in the flip-flop 4. So this is flip-flop 4. Okay, so this is where we can store n bit of information in a particular flip-flop. So if I want to store the 4 bits, I want to have 4 flip-flops. Therefore simply we can have a register is nothing but it is consisting of one input and one output. Internally we can define that n bit of information or else n bit flip-flop. So n bit flip-flop. Say for example, if I want to store 4 bits, internally I need to have these 4 flip-flops internally in this particular register. So this is what a type of concept called here registers. So for the in order to design a register, we need to have the flip-flop. So basically flip-flop is 1 bit memory cell. So now to increase the storage capacity, we have to use group of flip-flops. So here I am using group of flip-flops. If I use 4 bits, I need to have 4 flip-flops. So this group of flip-flops is known as registers. And I can have the n bit registers and consists of n bit flip-flops, n number of flip-flops. It is capable n bit word. So this is what the basic concept called register. And moreover, if you consider the register concept, say for example, um, if I want to store this bit particular 1101, so how much time this 1101 will store in this each flip-flop, so which is dependent on the frequency of we use say for example, if we use frequency as 1 megahertz, uh, and correspondingly time period T is equal to 1 by F. Therefore, T is equal to 1 by F means T is equal to 1 by 1 megahertz. So, almost it is similarly equals to 1 microsecond. So, the time period T, this is time period T. So, up to 1 microsecond, the data is stored in this particular flip-flop 1, 2, and 3, and 4. After a particular time period, the next data will be stored in this particular flip-flop. So we can do the in by using the concept of registers, we can do the operations called here shifting operation, and then we can loading operation also, or else we can call that as a memory operation also we can do. So this is what the concept regarding to the register. Okay, now data formats and classification of registers. So how we will give the data format and how we will get the output. Let us consider 4 flip-flops. So in this 4 flip-flops, how we will give the input. So basically the input can be given in two methods. One is series and another is parallel. So you can give your input in the format of series or else parallel. Parallel format. So let us consider if I consider these are the 4 flip-flops. So flip-flop 1 and 2 and 3 and 4. So if you give your input in this particular direction, so in the serial format one after another, you will get your outputs either in parallel mode, either in parallel mode, or else you will get your resultant as either in the series mode. So depends on the data format. So the data format can be given in the series format or else in the parallel format. Even in the output also we can get in the series format or parallel format. And now classification of I will show you data formats, how the data formats will be shown in the next step. Now classification of registers. Basically classification of registers are categorized into two categories. One is depending on the inputs and outputs. Depending on the input and output, we can categorize the flip-flops. So this is our first category. And second one is depending on the application. Depending on the application. Now, depending on the input and output, again categorized into four ways. The first one is serial input, serial output. This is first one. And the second one is serial input, parallel output. And the third one is parallel input, parallel output. And the fourth one is parallel input, serial output. These are the four categories we need to discuss depending on the input and output. And whereas depending on the application, the first one is shift registers, shift registers, and second one is storage register. Storage register. These are the two types of depending on the application. Here, depending on the input and output, as I explained just now, data formats. The data format can be given in the series and parallel. So now I am considering the way I am giving my input as serial and the way I am getting my output as serial. And here serial input, parallel output, and parallel input, parallel output, and parallel input, serial output. Like we are giving the input and output based on the series and parallel concept. And depending on the application, so the application can here we can have the concept here shift register. That shifting can be done either by the left side or by the right side. So the shifting can be done the left side or right side can be done, or else around the carry also we can do the shifting operation. And storage register, storage is nothing but loading operation can be done. So this storage can be observed in this particular parallel input serial output. So parallel input serial output is an application of the storage register also. We can call this as a storage register also. So I will explain how these can be categorized and how it will be done the operation. I will show you how CISO, how SIPO, PIPO and PISO and shift registers and storage registers. And along with this we need to discuss control buffer register, control buffer register, and bidirectional register, and universal shift register. Universal shift register. Okay, these are the concepts we need to discuss. Now I will show you. So we can observe here serial in, serial out. So the data input I am considering here in the serial manner, and I am getting my output as serial output. So the first concept is serial input, serial output. So I am giving my data in serial manner and I am getting my output as serial manner. Therefore we can have this as a serial in, serial out. And as I said now, shift register. Shift register can be done in the two methods, either left or right. So here my shifting operation also can be done in the right side operation. Therefore serial in, serial out, shift right register, this is what. And if you do the operation in the left side, then we can call serial in, serial out, left shift is happening here. This is what CISO for left and right registers. And now I will show you serial input, parallel output. So this is what serial input, and I'm giving my serial input in the serially one after another in the right side direction, and I'm getting my parallel output for each flip-flop. That is called parallel data. So this is called serial input, parallel output. And the next one is parallel input, parallel output. I am giving my input as parallelly and I am getting my output as parallelly for from each flip-flop. That is what parallel in, parallel out register. And the next one is parallel data and serial input, that is called PISO, PISO. So parallelly I am giving my input for each flip-flop and I'm getting my output as serially. So this is what parallel input, serial output. And we can have the as I shown in this particular two concepts, serial in, serial out for left and right, we can have in the single concept only. That's what bidirectional shift registers. As I said here, so we need to discuss control buffer register and buffer register and bidirectional and universal shift register. So in a single logical circuit, we can have the both the concepts of left and right shift operation. And along with this left and right, we can have one more point is here: rotate right shift register and rotate left shift register. So we can, if we want to do the operation of rotate left and right like this, for example, if you want to shift the data, say for example, the one is shifted to this particular position, this one is shifted to this particular position, and this one is particular shifted to this position, and 0 is shifted. So the whatever the rightmost number, that will be end around here, which is nothing but rotation with respect to the right side. So that is what you can observe here. We'll explain you later. And this is rotate left shift. So the rotate left shift, these are the type of registers based on the input and output, and along with the shift registers and storage registers. So this is what the concept of introduction to registers and data formats and classification of registers and types of the registers. And in the next video lecture I will explain about CISO, a separate video lecture, SIPO, PISPO and PISO. And along with this, the next video lectures will be shift registers, and then control buffer register and bidirectional and universal shift registers. Okay, thank you.